Hello dear students. So in this video we will be discussing Ray Optics PYQ from April 2024 attempt. Before this we have discussed your January attempt questions also. The link for the video you can check in the description below. If you find our video helpful, do consider to press the like button and subscribe to our channel. Let us start with this video. Yes. So let us see. The first question that we have, it is your 4th April shift 1 question. It says an effective power of combination of 5 identical convex lenses. 5 identical convex lenses are there. Let us draw them. So like this, 2, 3, 4 and 5, right? 5 identical convex lenses are there which are kept in contact along the principal axis. That means they are placed close to each other. The power of this is given to us 25 diopter, right? The effective power of this is 25 diopter. The focal length of each of the convex lenses. Fine. Let us see. So because they are identical, obviously focal length will be same only, f, each one will be having focal length f. What is our effective focal length? This is what is given to us. First of all, let us calculate effective focal length. So effective focal length 1 by f effective will be equals to 1 by f plus 1 by f plus 1 by f plus 1 by f plus 1 by f. That is your 5 by f. Directly I am writing. I hope it's okay with you guys, right? This. So when we calculate it, basically they have also given us 1 by f effective, right? They have given us power. From power we can calculate your focal length. So 1 by f effective is nothing but your power, which is equals to 25 diopter. It is given to us 25 diopter. Let's substitute over here. So 25 is equals to 5 by f. From this we get f is equals to 5 by 25 meters. This will come in meters, right? Because whenever you have diopter, basically when you have power in diopter, basically focal length will be in meters. So let us convert it into centimeter. It will be into 100, 25, 4 times. So focal length of each lens comes out to be 20 centimeter. Focal length comes out to be 20 centimeter. Option is there. Let's move to the next question. Yes, next question. A light ray is incident on a glass slab of thickness 4√3 centimeter. Let's draw the figure. So a slab is there, rectangular slab. Its thickness is 4√3 centimeter and refractive index is √2. Mu is equals to √2 given to us. The angle of incidence is equals to critical angle for the glass slab with air. Okay. So let's suppose that light ray is falling at some angle of incidence over here. Let's say that this is the situation given. This is your light ray falling at an angle of incidence I. And in the question they have mentioned that angle of incidence I is equals to theta critical for this glass air combination. Fine, well and good. This is what the condition is given. Then they are asking the lateral displacement of the ray after passing through the glass slab in centimeter. Okay, let us see what is going to happen. Over here light is coming from air to glass, that is rarer to denser, so it will bend towards the normal. After this light is going from denser to rarer, so it will bend away from the normal. It will bend away from the normal. In this case what happens is that the net deviation at the 2 point comes out to be 0. The net deviation comes 0, but the light ray shifts from its original path. This actual path of the light ray was this, but due to 2 refraction it shifted from its original path. This is what we call as your lateral displacement. So this is our lateral displacement. Let's call it LD. What is the relation for lateral displacement? Relation for lateral displacement is P by cos R sine of I minus R. I hope you know this. If you don't know, please write it down, right? So lateral displacement is T by cos R sine of I minus R. Now, do we know angle of incidence? No, directly it's not given to us, but it is given that angle of incidence is theta critical. Do we know angle of refraction? This is your angle of refraction over here, this. Do we know? No. So that means we have to calculate I, we have to calculate R, and then substitute in this. Let us calculate. So angle of incidence is basically theta critical. Directly we can calculate sine theta critical is equals to, for air glass, it will be 1 by mu. So sine theta critical is equals to mu value. Mu is given to us √2. So 1 by √2. That implies theta critical value comes out to be 45 degrees. Theta critical 45, that means angle of incidence is also 45. It is given to us in the question. Fine. So this is something that we have got it. Now we have to calculate R also, that is angle of refraction. How we will calculate? Using Snell's law. Let's apply Snell's law over here. Mu1 sine I is equals to mu2 sine R. At this interface, air glass interface, 1 into sine 45 is equals to √2 into sine R. When you will solve it, sine R value will come out to be 1 by 2 and R value will be 30 degrees. R is 30 degree. I we got it, R we got it. Now let's substitute in our lateral displacement formula. T is 4√3 centimeter. We'll keep it as centimeter only because in question also they have asked us LD in terms of your centimeter. So cos R will be your basically 30 degree, cos 30 sine of 45 minus 30. 45 minus 30 will be 15, sine 15. In the question they have given to us 0.25. So 4√3 by √3 into 2 into sine 15 is given to us 0.25, that is 1 by 4. So what we are left with, 4 cancel, √3 cancel, we are getting 2 centimeter as our answer, right? So the lateral displacement, that means this, the shift in the light ray will be of 2 centimeter. I hope it's okay. Let's move to the next question. Yes. So next we have a theoretical question. Let us see. When the white light pass through a prism, the red light bends lesser than yellow and violet. Is it true? Let us check. From your knowledge, you may be knowing it that whenever a white light is sent, the 7 colors split in such a way that 1, 2, 3, 4, 5, 6 and 7. So the 7 colors that split, they are VIBGYOR, like this. Okay. Red is the one which bends least. This is how the bending happens in case of a prism, right? Now why it is happening like this? Is it true? Yes. Is there a reason for it? Yes. What? Basically we know out of this VIBGYOR, red has maximum wavelength. Lambda is maximum for red, whereas for violet your lambda is minimum. If we compare between them, lambda minimum, over here lambda max. What is the effect of this? If we look at refractive index is C by V, which we can write as C by F lambda. If lambda is more, refractive index will be less. If refractive index is less, that implies the bending of red will be minimum. That is the reason for all these different colors, all these 7 colors, your refractive index is different. For all these 7 colors, refractive index is different, and refractive index is minimum for red because its wavelength is maximum. And if that is the case, the bending for, because it is mu is minimum for red, the bending for red is minimum. Now let us, so statement 1 is correct. Statement 2, the refractive indices are different for different wavelengths. Yes, it is true. In dispersive medium, in the light of above statement, choose the correct answer. I think statement 1, statement 2, both are correct, right? Let's move to the next question. Okay, again we have got a prism question. Let's see. The refractive index of a prism mu is equals to root 3 and angle of and the ratio of angle of minimum deviation to angle of prism is 1. Fine. Let's draw the situation. Let's say this is our triangular prism. This is angle of prism A. Refractive index is given to us root 3 and it is given to us that D minimum, that is deviation minimum by A, is equals to 1. Ratio is 1, that means they are equal. The value of angle of prism is, okay, we have to find out A value. How we do it? Beta, what is the relation between refractive index and your minimum deviation and A? We write mu is equals to sine of D minimum plus A by 2 by sine of A by 2. A very standard result, right? This is a very standard result that we have. So now let us use this. Mu is equals to root 3. I'll substitute all the values. Root 3, this is equals to sine of D minimum and A are equal. So in place of D minimum, I am keeping your A. So A plus A, 2A, 2A by 2 divided by sine A by 2. 2 cancels out. We have root 3 is equals to sine A by 2. Let's see, over here we can use sine 2A relation, which will become basically sine A can be written as 2 sine A by 2 cos A by 2 divided by sine A by 2. Sine A by 2, sine A by 2 cancels out. So we are getting cos A by 2 is equals to root 3 by 2. Cos A by 2 is root 3 by 2. That implies A by 2 is 30 degrees and A is 60 degrees, right? Angle of prism comes out to be 60 degree. I hope it is okay. Let's move to the next question. Yes, our next question, it is your 6th April shift 2 question. Let's see. For the thin convex lens, the radii of curvature are 15 centimeter and 30 centimeter respectively. Let us draw the situation. So a convex lens is there, the radii of curvature 15 and 30 respectively. Fine. The focal length of the lens is 20 centimeter. The focal length is given to us 20 centimeter. R1 and R2 are 15 and 30 centimeter. Okay, the refractive index of the material is, okay, let's see. So refractive index of the material. What is our lens maker's formula? We'll be using lens maker's formula. 1 by F is equals to mu minus 1, 1 by R1 minus 1 by R2. Over here I have considered, obviously it's nothing is mentioned, so outside medium will be considered as air. Okay, well and good. Now let's assume light ray is coming from this side. So what can we write? 1 by 20 is equals to mu minus 1. R1 will be positive because the radius of curvature is in the direction of incident ray. So we have to use sign convention. R1 is positive, which will be 1 by 15 minus of R2. R2 will be negative because the center of curvature for this surface is towards left. So we'll be going opposite to incident ray. Will be going opposite to the incident ray to measure R2. That implies R2 comes out to be negative. So I can put over here minus of minus 1 by 30. Let's simplify this. 1 by 20 is equals to mu minus 1. This I can make it 3 by 30. This comes out to be 3 by 30. 1 time, 10 times, cancels out. So finally we get mu minus 1 is equals to 1 by 2 and your mu value is equals to 3 by 2, right? Mu value is equals to 3 by 2. Let's move to the next question. Acha, 1 minute. 3 by 2, I think you can do it. Options are given in decimal, so it will be 1.5. There is not an issue, simple story, right? It's 1.5 will be our answer. Yeah. So the question we have, critical angle of incidence for a pair of optical media is 45 degrees. That means theta critical is given to us 45 degrees. The refractive indices of the first and second media are in the ratio. Okay. So it's a direct formula based question. Sin theta critical, what do we write? Sin theta critical is written as mu 2 by mu 1. Mu 2 is the rarer medium, mu 1 is the denser medium. Fine. So sin 45 is equals to mu 2 by mu 1. From this we can write down 1 by root 2 is equals to mu 2 by mu 1. So from this we get mu 2 by mu 1 is equals to root 2 by 1. Root 2 by 1. So our answer will be root 2 is to 1. Let's move ahead. Yes. So let us see. The next question that we have, I have drawn the diagram for myself. It's there for you people on the board. Let's see. Find the position of the image formed by the object O by the lens combination given in the figure. Fine. Let us see. So beta, as you can notice over here, there are three lenses. As you can see, there are three lenses. There is a convex lens, there is a plano-concave lens, and there is again a convex lens. And they are not placed close to each other. They are placed at certain separation, 5 centimeter, 10 centimeter, right? So how to deal with it? It's a question of your multiple refractions through lens. We will go one by one. Let's call this as your lens 1, this is lens 2, this is lens 3, right? First of all, let's focus on lens 1. So refraction through lens 1, L1. In these type of question, we always focus on the light ray. In these type of question, we always focus on the path of the light ray. So through lens 1, this is object is placed at 30 centimeter, focal length is 10 centimeter. Let us find out the image. So image in this case, V is equals to UF by U plus F. U value is 30, with sign convention it is minus 30. So minus 30 into F is 10 divided by minus 30 plus 10. How much we are getting? Minus 300 by minus 20. V value comes out plus 15 centimeter. Now see this. V is coming plus 15 centimeter. That means the light rays which are starting from the object, after refraction they will meet at a distance of 15 centimeter. Let us draw the ray diagram. This is 10, 5, 15. See over here. So this was the light ray, initial light ray, incident ray. They refract and from here they go at 15. 15, if you notice, is this way over here. The light were supposed to go and meet at this specific point. They were supposed to go and meet at a 15 centimeter distance. But in between, what has happened? Your plano-concave, this plano-concave lens has come. That means this image I1, I am calling as I1. I1 is the one which is forming after first refraction. This I1 will act as an object for your second lens. So let us write down. So I'll write it over here. I1 acts as object for lens 2. Lens 2. What will be the object distance? It's a virtual object, obviously, and object distance is 10 centimeter. Positive or negative? Positive, because this is the direction of incident ray. These are the incident rays for the second lens, and we are measuring the distance, object distance in the direction of incident ray. So U value will be your positive, which is plus 10, and your F value is given to us minus 10 centimeter. I hope it's visible to you down. Now let's see second refraction. Refraction at lens 2, L2. V is equals to UF by U plus F. U value is plus 10, F value is minus 10 divided by plus 10 minus 10. In the denominator we are getting your 0. In the denominator we are getting 0. That means V value is coming out to be 1 by 0. This is basically your minus 100 by 0, which implies V value is infinite. Interesting. V value is coming infinite. That means after second refraction, the light rays are going parallel. After second refraction, the light rays are going parallel. This is what is happening. See, I have drawn the path of light ray. After second refraction, V is infinite. So after second refraction, the light rays are going parallel. These light rays will behave as your incident rays for the third lens. That means what is the object distance for third lens? For third lens, object distance is your infinite. Light rays are coming parallel, right? So these light rays will act as the incident rays for the third lens. So I can write over here object distance, so refraction at L3. Now it is a simple story, right? Refraction at L3 and U value is how much? Minus infinite. Why I am saying minus infinite? Because these light rays are going parallel. So for this, now it's a simple story. We know that whenever light rays fall parallel to the, you can calculate also, or our knowledge also tells us that whenever light ray falls parallel to a convex lens, after refraction they will meet at the focus. They will meet at the focus, right? Over here. So the final image distance, I can call this as I3 also, which is our final image. It is equals to 30 centimeter. Why 30? Because the focal length of the third lens is 30. So finally V value will come out to be plus 30, and this will be our answer also. Plus 30 will be our answer. I hope it's okay. And always in these type of question, always focus on the path of the light ray. Do find out the refraction images one by one, and then also focus on the path of the light ray. Let's move ahead. Yes, so the question, it's a theoretical question. Two statements are given. Let's see. Statement 1. When an object is placed at the center of curvature of a concave lens, image is formed at the center of curvature of the concave lens on the other side. Let's see. Concave lens. They are saying that when object is placed this side, the image is formed on the other side. But this is very much wrong. From our knowledge, we know that whenever your object is placed in front of a concave lens, the image forms on the same side only. The image is formed on the same side only. This is what the situation is, right? So a concave lens always forms a virtual and erect and a diminished image on the same side of the lens. That implies the statement 1 is wrong. Statement 2, concave lens always forms a virtual and erect image. Yes, statement 2 is correct, but statement 1 is wrong. Let's look at the next question. Okay, let's look at the question. With this, we have come to our last question of this video. The following figure represents two biconvex lens L1 and L2 having focal lengths 10 cm and 15 cm respectively. So this one is 10 cm and this is 15 cm. Fine. The distance L1 and L2 is, okay, how to do this? Let us see. They have given us the path of light ray. When a incident ray which is parallel to principal axis strikes on this lens L1, it emerges out parallel to the second lens, from the second lens also. So they are asking us this distance, right? How to do it? But whenever a light ray comes parallel, after refraction from the convex lens, it passes through the focus. That implies this is the focus of lens L1. This is the focus of lens L1. That implies this distance is your what? 10 centimeter. Also, we are aware that if a light ray is emerging out parallel, that means the incident ray was passing from the focus of the lens. That implies this point is also the focus of second lens. This point is also the focus of second lens. If light is coming parallel, that means the incident ray must be coming from your focus of the lens. So this distance now finally becomes what? Your 15 centimeter. So D, the distance between the two lenses, we can write as F1 plus F2, which is 10 plus 15, which gives us 25 centimeter. So the distance between two lenses is your 25 centimeter, right? With this, we have completed. I hope you found the video helpful. Do consider to press the like button and subscribe to our channel. Thank you very much. Bye bye.